Yeah, welcome everyone. And thanks for turning up on this virtual event, which is a bit of a new one for me. I've not done an over-the-wire version of one of these, but you must be very dedicated to turn up to one of these without any free pizza. So thanks again for that. What I'm going to try and talk to you about today is scaling a GCP in a large bank, basically. Some of the challenges that we've had and how we're going about solving them. I'm James Betteley, Director of Technology. Those of you who've been around for years and years and years in this space will probably have bumped into me at some point in the past. And I am now with the wonderful Publicis Sapient. A little bit about me then before we move on. My background's in DevOps and continuous delivery and now public cloud stuff. And I work with financial services clients of ours. Some of them are listed there on the screen, as you can see, as a director of technology, basically a cloud consultant. This is a little bit about Publicis Sapient. We are relatively large, as you can see, 20,000 passionate people, 50 global offices, and we play very well with loads of big partners, the likes of Google, Microsoft, and you might think of our kind of competitors, as it were, as the kind of Accentures, Deloittes, and those kind of guys. But we partner with them, we work with them all the time. So we play very well with those guys. I have no idea why Samsung is above the line on this slide and not below it, as are all the others. It may be an in-joke. I don't know. Not my slide. Anyway. So that's us. I'm based in the UK in our UK office, but we're sort of dotted all around, obviously, wherever our clients take us. And as Andy mentioned just a few minutes ago, we're hiring. So we'll get onto that later on. So the thing I wanted to talk about is literally around why scaling is a challenge and how we're getting around to it. But it's worth stopping just to think about, first of all, what the actual challenge is with scaling. We're not talking about, for example, trying to scale Kubernetes services or applications on Kubernetes in GCP, because that natively scales, right? That's a problem that's already solved. We're talking about scaling within an organization and some of the non-technical challenges that go with that as well as the technical ones. And so on the one hand, especially in large financial services companies, large UK banks, very regulated environment. You've got these kind of compliance and departments and teams that we've got listed here on the left-hand side who provide a certain number of what you might kind of think of as constraints, but they're not necessarily. They're just trying to do their jobs. But you've got guys like risk, cybersecurity, service introduction, app security, multiple design authorities and architecture teams, and I think a few of you might be familiar with the cloud control frameworks that are around that do require us to have lots of things like documentation and stuff like that. And then on the other side, rather than having just a challenge of scaling the number of applications and their demands on the infrastructure, it's actually a problem of scaling with teams. And numbers of users. So you've got teams of all sorts of shapes and sizes. You can imagine now we're in a bank that's got tens of thousands of people, dozens and dozens, hundreds of teams or whatever. Every imaginable kind of application of every shape and size, even down to sort of mainframes and stuff like that. And some of the teams have got absolutely no cloud maturity. They really want to get on board, but they've not had a chance to play with it in the past. Then you've got teams with cloud SMEs who've got loads of past and relevant experience in cloud, and teams that have got SRE capabilities and some that don't. And as I say, just a lot of people. So how do you cater for the needs of the one extreme and the other, and build a platform that caters for all of them? That's the scaling problem. And also chuck into the mix that, it's not just the GCP landscape. I'm going to talk about the GCP landscape, but if you think about it, there's a bit of hybrid and multi-cloud there as well. So it all rolls up to be one big scaling problem. And more specifically around the GCP side, you're also looking at how do you scale things like the security guardrails, how do you make sure everything is scalable, how do you make sure everything is compliant, and how would you scale the onboarding experience and all of that kind of training and upskilling too. So there's multiple questions there to try and answer, which I'll just try and whiz through. I will focus on just a couple of things maybe that I think you might find interesting, but generally speaking, I'll just go quite high on these, and if you've got any questions, just ping it into the Q&A. Real big driving factor here and a huge differentiator is the guiding principles. I can't stress how important I think these are. It's super important stuff around helping you make the right decisions or around all the choices that you have around how you architect and what kind of services you offer to everybody. These are some of the ones that the CCOE, the Cloud Center of Excellence, and the platform engineering team came up with. So we work hand in hand with our clients, and this has all been a collaborative effort. And these core principles have been driven out of the work that they've been doing, and I think it's really, really important to stress this. So cloud native solutions you should always go for a cloud native solution, and we're trying to move to a cloud native future. So move away from some of the traditional on-prem, perhaps, ways of doing things, and break into the new world. Automation, everything should be automated. There's no workarounds. There's no manual stuff. You leave your tech debt behind in terms of automation. So everything from the way that apps are deployed, you're managed, everything. Security. The platform security posture is absolutely key, and everything should be automated in that act of ensuring that platform security is adhered to. So we'll talk about the security guardrails a little later on. And then inner sourcing. There's so much code going on here. Everything is code that you'd quickly become a bottleneck if you try to manage it all yourself. So to be able to scale effectively, think about having a good in-source model. And then finally, scalability and resilience. The platform should be designed to support one of the UK's largest banks. So you design it with that in mind. You've got recovery point objectives and RTOs that are absolutely critical. So this has to be at the forefront of your thinking with all the design decisions that you make. Before we go much further, I want to talk about a Cloud Center of Excellence and what is it, and do you really need one? It's a question we hear quite a bit. Is there a right time to stand up a Cloud Center of Excellence? Yes, I think there is personally, that at a certain level of maturity, you do need one. But if you look at the stuff that's on the right-hand side, things like the infrastructure enablement, application build and testing, things like CI/CD platforms and container bakeries, image bakeries, monitoring, alerting, and stuff like that. Someone's got to build all of that capability in the first place. And for us, it's been a platform engineering team. And as you can see from the diagram on the left-hand side, the structure on the left-hand side, that platform engineering team is kind of is integral to the Cloud Center of Excellence, and it is in there. So that's where the angle we've come at this, and I think that it's good to remind ourselves that the Cloud Center of Excellence is there as an enabler. It's not an owner of this stuff. It's not the doer of all of this work. You can think of it as maybe bootstrapping some of it in the first place, and there's kind of a little bit of an overhanging ownership shadow there. But really, it's an enabler. It's there to just get people on board. Help people get the cloud experience, provide the functions that they need if they don't have their own core skills to be able to develop them themselves. So act as a bit of like burst out capacity, if you like. But really, it's as I say, the key word is their enabler, not the doer of all of the stuff that's in those boxes. So we have this concept of products and services. This is another key aspect of how we think we're going to manage scaling. So if you think about the services are the ones on the bottom side of the slide. Essentially, these are the things that are curated by the Cloud Center of Excellence and then offered as services to the consumers. So whichever lab, team, department, or whatever you want to call them, when they're on board, these are there as a sort of pay-as-you-go kind of thing, platform as a service almost. It's there up and running and they just consume it. And then there's the products. And the products, which are on the top there, is a whole list of basically blueprints. So these are repeatable patterns for how to spin up and configure and then consume these things. But crucially, you own them. They become yours. So as a lab, as a product team or whatever, you might decide that, yes, I want Cloud SQL or cloud storage or something like that. Then, yeah, you there you go. There's your blueprint. There's your load of Terraform scripts that you basically use to provision and configure. And away you go. It's yours to look after. Similarly, if you've got some new demand for a completely new product or service, then the Cloud Center of Excellence will be there to help you build that as well if you need to. But of course, with that in a source model, it can work in any kind of way. So that's a key aspect, I think, because if everything was a service and the Cloud Center of Excellence was responsible for running and maintaining, upgrading and evergreening all of these services, then you'll just be a bottleneck. And then you'll have a whole scaling the CCOE challenge. And as I mentioned before, obviously the CCOE can't be that bottleneck. It has to be the enabler. So if there was ever a slide that needed some animation, this is it. But this basically demonstrates that the foundation is to make everything scalable is that everything has to be a building block. So everything from things like the security guardrails, which we'll see later on, they're built in with Chef InSpec for the infrastructure. The service mesh is again Istio. It's got its own building block, Kubernetes orchestration, container bakery, CI/CD patterns, and IPAM, which we'll get onto I think shortly. So all of this, they're individual building blocks, kind of almost like loosely coupled services that you can consume. So we'll take a look at some of these. First of all, the Terraform provisioning. So why Terraform? Well, it's cloud agnostic, obviously, and it's very, very popular. So it's easy to work with. A lot of people with a lot of experience in it, and highly transferable. So that's great. And we've got, as you can see, or what I'm going to demonstrate is we've just got Terraform templates for basically everything, every service, every single product. There's a Terraform template, even obviously down to the sort of the project and folder structures on GCP, a whole Terraform structure for that, Terraform scripts for that. Yes, it's tremendously prescriptive, and that's the point. With it being tremendously prescriptive, we can scale. If it wasn't, and everyone had their own way of rolling their own with their own Terraform scripts, then we wouldn't. It would be very difficult to manage and very difficult to scale it. So yes, a very prescriptive approach, very prescriptive framework. And as Andy was alluding to earlier in the previous talk, the users seem to be quite happy. They want something prescriptive. So far so good with that. We've not had anyone who's screaming to do something in a wildly different way. So essentially, how this works is when a lab or a team onboards, they want a GCP environment setting up. They clone a repo and update some of the variables with their project details, and then the project resource templates each contain Terraform TFRs files, and then for the resources that they want, they populate a TFRs file. If they don't, then they don't get that resource. It's as simple as that. So that's it, and then that then goes and spins up an environment for them, and it's all orchestrated via Jenkins. Essentially, we'll get onto Jenkins in a minute, but basically, there's a Jenkins file which you add your details to, and then that creates a job in a shared Jenkins instance. And you fire go, and off it goes, and provisions all of the stuff, all of the resources that you specified in the TFRs files, and that is it. What kind of structure do we use? We've got obviously the project folder hierarchy. We've gone for the organization, then environment, then domain, then project structure, simply because it's on that the environments and domains are obviously the folders in GCP, if you're familiar with that. Why have we done that? That's simply to allow us to set up different kinds of policies at the folder level. So, for example, if someone wants to set up, let's say, a load balancer, then you can say, yes, you in the dev environment or pre-prod or whatever, or a test environment, yes, you can, but in prod you can't, or something like that. So it gives us that sort of fine-grained control over what people can and can't do, and IAM and things like that. So yeah, another one on Terraform provisioning, but basically just underlining the same point that essentially it's there's a template for everything, and that extends to things like managing Kubernetes with these Helm charts and stuff like that. Actually, we're now using the native Terraform Helm provider now, so we don't need to do that bootstrapping of the VM. So and eagle-eyed viewers of some of these wording in here would notice that some of it might not actually be relevant at the moment. But yeah, essentially, a whole heap of template code in Terraform that allows people to go off and essentially get up and running very quickly, using exactly the same modules and exactly the same template. So we're not completely reinventing the wheel all the time and doing things in crazily wild different ways just to achieve the same end goal. One thing that we've had a challenge around is IPAM. Obviously, we're on GCP, so and we're in a huge enterprise estate, so we needed an automated approach to IP address management, and the GCP approach of either dynamic or manual didn't really work. So what we've done is come up with a bespoke approach, which is basically a Python-based program. And that basically breaks down the IP ranges into subnets and allocates them when things are being provisioned and spun up, and when teams are on board. And then it registers them as used or allocated. And then in the back end, it's got a cloud data store, which basically keeps a registry of all of the networks, subnets, and IP addresses, and whether they're allocated or not. And then that job runs every 20 minutes to basically check, loop through your subnets to see whether those IPs are still allocated or not. So that's in hand. It's worked in the GCP network rather than the hybrid or on-prem at the moment, but we'll sort of bridge that gap as well when we get to it. Scaling CI/CD. As I mentioned earlier on, Jenkins is pretty integral to what we do. All the way from like setting up your initial environment for a new team that's onboarding. It's all bootstrapped by Jenkins. Then beyond that, so what you need is a scalable solution and CI/CD for both infrastructure. And we follow a GitOps approach as well as applications. And then Jenkins as an orchestrator, essentially, there's two different flavors. We've gone for a centralized Jenkins approach for all of the infrastructure, and so all the bootstrapping of the environments and the provisioning. So as I said earlier on, when you clone a repo, there's a Jenkins file in there which you update with your project details. You log into Jenkins and kick off a pipeline, and that does all of your provisioning and of your environments. And that's like almost like a one-off kind of event. So that's done. But you also get as an application or a project team or a lab or whatever you want to call yourself, you also get your own Jenkins cluster for doing your own application CI/CD, and that's hooked up to Spinnaker. So your deployment control passes over to Spinnaker, and it's all orchestrated via via Jenkins, but you'd log in Spinnaker then subsequently and watch all your deployments flying across all your various environments. That's the idea anyway. So it's the same, essentially, in order to make it scalable, one single central Jenkins for the infrastructure CI/CD, and then we've got the Kubernetes clustered Jenkins for every project team, and they manage that themselves, but essentially follows the same kind of patterns. Where we go next? Oh, Istio. Istio configuration, a bit of a popular one at the moment, I understand. We've gone down the route of obviously Istio as a product, not a service. So this means that you've basically got a blueprint. So we've got a whole load of Terraform scripts which spin up and configure it. So that the blueprints will give you things like patterns for ingress gateway, cert manager, and so on. But you've got big questions around your design of your Istio configuration. So before you even do spin this up, you'll need to know whether you're going to want a single or multiple cluster, how many networks, you've got one or two networks or more, and then the question of a replicated control plane or a shared control plane. Demonstrated there a picture of the shared control plane, with obviously the risk being with a shared control plane, you've got a single point of failure there where your shared control plane is in one cluster. But if your control plane is in a replicated control plane configuration, then you've just got a bit of a replication nightmare and a headache, and that makes scaling a little bit more challenging. We were upgrading to 110, and I understand that the general push is to go to a replicated control plane configuration. I'm not entirely sure why. But we're also looking at Anthos service meshes just to make the whole thing a little bit easier. I spoke about security guardrails, and I said I'd mention them earlier. And sorry for the not great slide here, but this is super important stuff for all of the infrastructure automation, all the services and all of the products. The security guardrails are absolutely essential. And so we use Chef Inspec as a way of ensuring that all of our compliance is tested and all of the compliance is actually built into the Terraform. We work exceedingly closely with all of the security teams, the compliance team and the cloud control framework teams to identify what the guardrails are, create a library for what those guardrails need to be, enforce it centrally using IAM, create inspec policies for it, and Terraform modules, and then set up alerting and remediation for whenever anything gets out of sync. And that's basically the route for ensuring that our infrastructure is always compliant. If this stuff is up your street, then please do head over to the London DevSecOps gathering. It's a really good group of people there who are really passionate about DevSecOps, and this kind of stuff often comes up. So I've learned a lot from those guys. So yeah, please go and check them out. Again, going back to something that Andy was mentioning in the previous talk, this is around the levels of maturity of the teams that are on board or perhaps don't on board. And we talk about this thing around license to operate almost. I know it sounds quite bad, but basically what this is ensuring that the teams who are onboarding have got the necessary skills and levels of technical know-how to be able to manage and run the environment. So there's a few kind of prerequisites. It's not overly stringent. It's not like sorry, if your name's not down, you're not coming in. But it's ideal if you have things like strong DevOps, a bit of SRE capability within your team, definitely some security and compliance engineering, but teams that have got good experience and capability for managing their own infrastructure as well as their own route to live CI/CD processes. because in some of these large organizations, especially in the financial services world, a lot of the development teams have been very disconnected from anything beyond the dev environment, thanks to lots of compliance issues, security, Sarbanes-Oxley, and all of that kind of stuff. So I tend to, not to mention for other reasons like contracts and partners having ownership of that side of the thing anyway. So they might hand it over to a team that takes over all of the deployment through all of the various different environments, and that's the last time they see it. So the feedback loop is hugely elongated from when something goes in, when you finish a piece of coding and when it goes into production. So over the years, the teams have just really not developed the kind of skills around how to deploy, do things like A/B testing and canary releases and all of that kind of stuff. Because it's been so far away from them. So a lot of the teams are just don't have that skill. So they're now having to develop these skills and bring them in-house. So yeah, if you're going to onboard, then you need to at least be on that journey and be able to demonstrate that you can do these things and now take full end-to-end ownership of your code going through all these various different environments, because nobody else is going to be there to support it anymore. The CCOE isn't going to do first line, second line, third line support. It's not even going to pick up your cluster if it falls over. These are the things you've got to manage yourself. So obviously, one of the things that's absolutely paramount for scaling is upskilling. So being able to actually ensure that the teams who are onboarding have got the skills and the relevant technology experience to be able to run with it. Another reference to team topologies is how we're scaling onboarding of teams and new platform features. So labs there, we may call that a department or a team or something like that. But basically, when a lab onboards, they have a bit of a sort of a handshake with the Cloud Center of Excellence, and that Cloud Center of Excellence will help them get onboarded as an enabler. I keep saying that word. But then beyond that, sort of day two and beyond, there's various other things that various other ways of interacting. So SRE, as you can see there, is a kind of, it may live wholly within the lab, may live partly within the lab, but in real life, there's going to be a certain degree of crossover between the CCOE and the lab itself. So they'll be working hand in hand. Might get more privileged access to parts of the platform and things like this. And also, if a lab has got some funky new requirement that hasn't already been built as a product or a service by the CCOE, let's say something like Anthos Service Mesh, for example, migrate for Compute Engine, AutoML, Cloud Run or Cloud Functions, something like that, let's say, then they're responsible for building it. We've got this inner source model, as I mentioned before. So it will be between the lab and their SRE guys to collectively make this a real thing. All check it all into the same code base. Obviously, all be built with Terraform scripts, and the CCOE will be there to make sure that it's compliant and there's inspec, and that the pipelines that are building it and checking it are doing what they should do, and all of that good stuff, and that it complies to service introduction requirements. So that's the way that we envisage kind of interaction and creating of new features. So hopefully quite scalable. And that's pretty much it.